All right, what I have here is I have y equals inverse sine of 5x, and I want to find its derivative. And I'm going to appeal to an implicit derivative strategy. So if y is the inverse sine of 5x, how else can we write this? I'm going to say sine of y equals 5x. And then what? Well, if I'm using an implicit derivative property, I'm going to take the derivative with respect to x of sine y is going to equal the derivative with respect to x of 5x. Now, the derivative of sine of something is the cos of something times the derivative of the something. So the derivative of sine of y is cos of y times what? Cos of y times the derivative with respect to x of y, also known as dy dx, is going to equal the derivative with respect to x of 5x, which is 5. And then we're going to say dy dx is 5 over cos y. Now, we're not finished with this. We need to figure out what cosine y is as a function of x. But let's go back to this line right here. Sine of y is 5x. Let's write that down. Sine of y is 5x. And I'm even going to think of it as sine of y is 5x over 1. We also know that sine is opposite over hypotenuse, right? So sine of y is opposite over hypotenuse. So let's think about this for a minute. Can we make a triangle that satisfies these conditions? Well, sure, if the opposite is 5x and the hypotenuse is 1 for an angle y, that will satisfy that. So let's go ahead and construct that triangle. Here's the triangle. Here's the angle y. The opposite is 5x and the hypotenuse is 1. The third side is the one we're looking for. Let's call that b. How are we going to find b? If I know this side and I know this side, it is a right triangle. There is a mathematical tool that will enable me to do this. That, of course, is Pythagoras. A squared plus b squared equals c squared. So we will say 5x squared plus b squared equals 1 squared. 25x squared plus b squared is 1. We're trying to solve for b, or b squared. So b squared is 1 minus 25x squared. Normally, we would say b is plus or minus, but it has to be plus in the case of a triangle. So b is the square root of 1 minus 25x squared. Let's go ahead and make that label. So that's the third side of that triangle. And if we go back to where we were before, we said dy dx, or the derivative of inverse sine x, is 5 over cosine y. Looking at this triangle, what is cosine y? Well, cosine is adjacent over hypotenuse. So at this one, what are we going to say? We're going to say cosine y. Adjacent, we're at 1 minus 25x squared over 1. And we are just about finished with this part of our discussion. We're able to say then dy dx is 5 over cosine y. We just have cosine y here. And we have 5 over the square root of 1 minus 25x squared. So the implicit derivative approach is a good one here. You could have also gotten this by using the Pythagorean identity, cos squared theta plus sine squared theta equals 1. But what we've done is we've proven that the derivative with respect to x of inverse sine of 5x is 5 over the square root of 1 minus 25x squared. But now what I would like to do, I would like to reverse that process. Can I reverse that process? In other words, can I show that the integral of this function leads me to the inverse sine of 5x? And that is a technique we call trigonometric substitution. So let's do that. If I am attempting to do the integral 5 over the square root of 1 minus 25x squared dx, how do I proceed? Well, Just like the last problem, I am going to build a triangle. A right triangle. I will use theta as the angle this time. And one of the sides will be the square root of 1 minus 25x squared. It could be the horizontal side, it could be the vertical side, but it could not be the hypotenuse, because the hypotenuse would have to just be a single number or possibly an addition, but not a subtraction. So I'm going to go ahead and I'm going to put it here. So I'm going to make it 1 minus 25x squared. And I need to figure out what the other two sides have to be. Let's call this A and let's call this C, so that the results are friendly to us. Call the third side B for the sake of discussion. So this really is the hardest part of the problem. How do I work with this triangle to get something that satisfies all the conditions of the problem? Well, we know from Pythagoras, a squared plus b squared equals c squared. So a squared, fine, plus b squared plus root 1 minus 25x squared equals c squared. So we get a squared plus 1 minus 25x squared equals c squared. And here's your key idea. I would like this to get as simple as possible. So notice, I have negative 25x squared here. I'd like all the x's to go away. So if I let a equal 25 minus x squared, what would that give me? If a equals that, then I have 25 minus x squared instead of a, plus 1 minus 25x squared equals c squared. Excuse me, a is 25x squared, 25 minus x squared. A is 25x squared. Because now we have 25x squared plus 1 minus 25x squared. That's what's going to knock that out. So all that would be left, if a is 25x squared minus 25x squared gives me 1 is c squared, gives me c is 1. So in that case, now we have c is 1. And what is my a? We said a was 25x squared. If a is 25x squared, what would that make a? A squared, excuse me, is 25x squared. If that's the case, a is simply 5x. Okay. So now what do I have here? What do I have here? Sine of theta, opposite over hypotenuse, 5x over 1. We know that. Fine. That's nice. So let's write that down. Sine of theta is 5x over 1. So if that's the case, I could take the derivative with respect to x of both sides. The derivative with respect to x of sine theta is the derivative with respect to x of 5x. So cos theta d theta dx, cos theta d theta dx equals 5. So cos theta d theta equals 5 dx. So cos theta d theta divided by 5 equals dx. We have that fact. What's another fact that I need? Well, I need root 1 minus 25x squared, but you can see how that's cosine. Cosine is adjacent over hypotenuse. So looking at my triangle, cosine of theta is root 1 minus 25x squared over 1. Great. So cos theta is root 1 minus 25x squared. So I think we're in a good place. If we look at this now, here was my question. My question was the integral of 5 over square root of 1 minus 25x squared dx. What do we have? 5 is 5. Root 1 minus 25x squared is cosine theta. Dx is cos theta d theta over 5. We will notice the 5's divide out. We will notice the cosine thetas divide out. So this becomes the integral of d theta, which is just theta plus c. But what was theta? What was theta? Aha. What did we say earlier? We said sine of theta was 5x, which means theta is the inverse sine of 5x. So to finish this, my theta plus c is simply the inverse sine of 5x plus c. Let's do one more of those types of problems. We won't make it quite as clean as it was that time, but we're going to be dealing with an inverse sine. So let's look at the integral of 1 over the square root of 1 minus 49x squared dx. So I want to make a triangle. I believe that's the hardest part of this process. So we're going to make a triangle. Root 1 minus 49x squared has got to go on one of the sides. It cannot be the hypotenuse. It could either be this part or this part. I'm going to choose to put it here. Now let's think about this. If I square that, I get 1 minus 49x squared. If I want the negative 49x squared to go away, the other part would have to be positive 49x squared. So this guy squared gives me 1 minus 49x squared. This is the b squared part. Plus, I want the other piece to be 49x squared. That'll be the a squared part, which will give me a total of 1. That will be the c squared part. So if c squared is 1, that would make c equal to 1. If a squared is 49x squared, that makes a equal to what? Equal to 7x. So now we have our theta here. And we can go ahead and do our analysis. So looking at our picture, opposite over hypotenuse, sine of theta, opposite over hypotenuse, 7x over 1. Take the derivative with respect to x of both sides. Derivative with respect to x of sine theta is the derivative with respect to x of 7x. So cos theta d theta dx equals 7. Cos theta d theta equals 7 dx. Cos theta divided by 7 d theta equals dx. So we have that fact, which is nice. But also recognize here that what I have is I have root 1 minus 49x squared over 1. That would be cosine theta. Cosine theta is adjacent over hypotenuse. Cosine theta adjacent over hypotenuse. Root 1 minus 49x squared over 1. So knowing that cos theta is root 1 minus 49x squared, we should be able to determine this integral. So let's go back and look at what we have. This was our question. Integral of 1 over root 1 minus 49x squared dx. Root 1 minus 49x squared is cosine theta. Dx is cos theta over 7 d theta. The cos thetas go away. We get 1/7 integral of d theta, which is 1/7 of theta plus c. But what was theta? We said before that sine of theta was 7x, which means theta would be the inverse sine of 7x. So my final answer here would be what? Would be 1/7 inverse sine of 7x plus c. that is our answer to that integral. All right.